Was the last class we discussed? Anybody? In which unit we are? Anybody respond? What we are discussing? What is the present topic? What is the last class topic? And in which unit we are? Nobody.
Foreign network.
Foreign networks. Discussing about the mobile IP. Right. So in the first unit, we discussed about the mobile communication fundamentals and communication fundamentals, which is the prerequisite to get into the mobile computing environment. And also we discussed about the prominent protocol of the mobile computing environment, GSM protocol. Its architecture, its incentive facilities that are being made it popular around the globe. So how it is going to be accommodating that much number of millions of people to use the communication, mobile communication as a part and life, part and parcel of their life. Okay, so in the first unit we discussed about the fundamentals, and in the second unit we discussed about the MAC layer, that is the sublayer of the data link layer. Okay, so how it is going to be useful for establishing a logical connection and conveying the information from sender to the receiver. This is what we discussed in the second unit. And coming to the third unit, we got into the third sublayer, which is the third lower layer, which is helpful for establishing the network connectivity in between the two parties who are being communicating. Okay, that is going to be discussing in the third unit. That is about the internet protocol layer you are going to use. So as internet protocol layer is already there, we discussed about how it is been working, what are all the protocols, how the frames and data packets will be delivered, how the packet will be delivered from the corresponding network layer using the internet protocol from one party to the other party. All these are being discussed in the computer network subject. But what about this mobile IP? The third unit is about the mobile IP. So the normal communication, the normal network communication, what we are been discussing until right from the data communication, then we go on for the what is called as computer networks. Then we are going to discussing about the CNS and whatever it is. But the mobile communication is different from the normal IP communication, right? So for this mobile communication, how this IP layer will be useful for us. So with the existing equipment and with the existing protocols and rules and everything, how our mobile communication is going to be working. So that is what about the third unit that we are going to discuss. So we discussed about what is the need of the mobile IP, how it has been different from the normal IP, what are all the additional things we have to do, whether it is going to be accommodating with the existing IP network or equipment or protocols and whatever it is, we saw through. And what are all the other functionality, additional functionalities has to be performed by the IP in case of the mobile IP. In case of the mobile IP, that we what we have seen. Okay, and at the same time, we are also discussed about the goals of mobile IP. While introducing the mobile IP functionality, with which type of goals it has been introduced, so that it is going to be serving the problems of the mobile users. It is going to be giving you the bandwidth and accommodating the much number of users with the available space and with the available frequency. So all these type of different goals are there for introduction of the corresponding mobile IP. So with that particular mobile IP goals, what are all the different challenges the corresponding mobile IP has to face in real time, while providing the compatibility, while providing the security, while providing the efficiency, scalability, and all those things are nothing but the requirements and the challenges that are to be faced by the IP network layer in order to execute the mobile communication, right? So I also discussed about the requirements of the mobile IP. Thereafter, we are discussing about the architecture, that is mobile IP, how the mobile IP is going to be working. Okay, so now we'll see what we discussed in the last class, what could be the thing. So while discussing about the mobile IP, we do require certain terminology which has to be learned regarding the mobile IP. That is a different terminology. That is why, because in case of IP, that we know about only the normal communicating points, nodes, path, network, right? Routers, gateways, bridges, all these things will be there. Routing protocols will be there. Routing algorithms will be there, and these are going to be get considered. But while working with the mobile IP, we do have the different terminology and we do have the different entities. There could be the host, there could be the mobile nodes, there could be the static nodes, there could be the communicating stations will be there, controllers will be there, how the information will be conveyed, how the corresponding to subscribers will be get connected, how their route will be get identified. All these things has to be get known with. So to get aware with and to get familiar with the entities and terminology of the mobile IP, we are learning about certain standards which are belonging to the RFC 3344, which is the one of the standard of the mobile IP communication, among which we saw about the mobile node, which with which we initiated the mobile communication. Like it may be static or mobile, okay, and it is going to be having the capacity of having an IP address assigned to it, and it is going to be starting to communicate with the corresponding node, right? The corresponding node is nothing but a partner of that particular mobile node. Mobile node is nothing but from where the corresponding communication has been initiated, and the corresponding node is nothing but the partner of this particular mobile node, right? This particular correspondent node may also be, again, it may be a mobile, what is called as moving node, or maybe the static node, whatever it is. And home network is the network with which it is being associated. The mobile node with which it is being associated with the network is called as the home network. But as the mobile node, as we already explained, that it may be mobilized or maybe it's static. So while it is going to be moving, it is going to be crossing its home network and enters into the some other network which is not related to it, right? So while entering into that particular network, it will become a foreign body. Obviously, that network will be also the foreign network for the corresponding mobile node. So what about this foreign node? Foreign network, how we are going to continue our communication even we are being crossed with the home network and entered into the foreign network. So we have to get identified there, we have to get registered there, we have to continue the communication there, how that particular communication will be happen, how our address will be get identified, whether we are going to assign with any new addresses. That is what that can be taken care by a particular agent called as foreign agent in the home network. This is nothing but a specific router which will be assigning a subnet mask for us in order to get identified by the foreign network and to continue our communication while moving over. Whether we are moving or the correspondent node has been moving, our identification or our communication has doesn't to be stopped and it has to be continued. But without changing our IP address, without changing our actual identification, okay, is there any problem? Right. So that could be taken care by the foreign agents present in the foreign networks while entering into our new network called the foreign network. These foreign agents have been acting as a routers for us. They are providing certain identification for us using a care of address, and using that particular care of address itself, we are being continuing their communication without break with our correspondent nodes, right? And care of address is nothing but an identification address or IP point of view address or attachment will be given to us whenever we are moving from our home network to the foreign network. And this particular care of address is going to be helping us to convey our information from our side to the receiver side, right, at any point. So it has to be get tunneled. There is nothing but our identification has to be get masked up by this care of address. Actual identification will be masked by this care of address, right? This care of address will be used in two ways. That is what we discussed in the last class, right? It will be used in two different possibilities. One is the foreign agent and next one is a co-located. Foreign agent COA will be allocated to you whenever you are continuing the communication in the same network area until you complete the communication. That is the foreign agent COA. And coming to the co-located COA, in this particular co-located COA, our mobile node or ourselves are going to be moving continuously without staying at any place continuously, and you are not been completing the communication pertaining to a specific foreign network, then we will be allocating with many number of foreign networks with the co-located COA temporarily while you are moving. So, why? Because if you are in a journey or crossing through many number of foreign networks, leaving your home network. While crossing through the many number of foreign networks, we will be allocated with the co-located COA for our identification and to continue our communication. And that particular co-located COA will be the temporary one, as you are moving from the home network, not at all staying at least for a certain amount of time in that particular foreign network. So there is the co-located COA, which is the temporary one. So this is already been explained to you. This is how the networks are being arranged, how the home agent will be connected with you, and how the foreign agent will be connected with the other partner over there, or how particular home agent will be serving you whenever moving from the home network to the foreign network, right? So our mobile home or a mobile station will be allocated with certain address like 131.5.254.8. But when you are moving into the foreign network, we will be allocated with certain care of address, which is very different from our own host address. But it is going to be get identified and our communication will be get continued, right? So that is how the corresponding host agent will be, home agent will be like here in between us and the network, and the foreign agent will be there in the corresponding foreign network. But whenever you are moving this mobile host from this particular home network to the corresponding foreign network, this foreign agent will be acting as a router for you. That is also has been explained to you. So home agent is also going to be acting as in three ways. That is what we discussed. It can be acting as a router whenever you are going to be pertaining to the home network, and it is going to be acting as a subject mask whenever you are going to be what is called, when you are roaming over the foreign network, and it is going to be just acting as a manager when you are completely in the virtual network, right? So home agent can be acting as in three ways, and here what we have explained here is what the corresponding home network, whenever the user is going to be moving from home network to the corresponding foreign network, what happens, how the corresponding data will be moved over, how the communication will be taking place. There is nothing but the home agent router will be there, foreign agent router will be there, correspondent node or partner is here. He is having that particular correspondent node is having a router here. From this particular home network, our mobile station has been, our mobile node has been transferred or traveled to the corresponding foreign network. So in this case, our router will become a foreign agent router, right? Our foreign agent router will become our own router. But how the communication will be get continued? So whenever the correspondent node has to communicate with the correspondent, what is called as mobile node, which has been moved from the home network to the router network. But this correspondent node doesn't know about this correspondent mobile node. This mobile node is not going to be present in the home network. It has been moved over. So how it can be identified? But actually the communication link will be in between these two itself. That is the home network router and also the correspondent router itself. But what happens is whenever they start communicating, the corresponding communication link will be built in between the home agent router and the foreign agent router by the process of tunneling. By the process of tunneling, our address of the respective mobile node will be allocated with some care of address in order to find out the trace of this mobile node present in the foreign network. It will be get tunneled up and get forwarded to the router, foreign agent router. So there onwards, the communication starts between the respective mobile node and also the correspondent node with the help of the foreign agent router. So with the face of COA, it is going to communicate with the correspondent node. So here the encapsulation of the data will be done. That is the mobile node here encapsulates its data through the foreign agent router. Here, the home agent router is going to be tunneling your address from the home network to the foreign network using the COA value. So that is what we have discussed, and what here it is being explained in steps. Okay, so the router is going to be giving you communicating directly. The tunneling will be taking place in the second step, and in the third step, the address will be given to the MN, and using that particular address, the communication will be taking place in between the mobile node and the correspondent node. That is what given in the four steps, right? So already we discussed about how the data transfer in mobile IP and how the data transfer will be kept, data will be received in the corresponding mobile IP. So according to the 4 steps that we discussed in the last class, according to the 4 steps that we discussed in the last class, what happens, see, when we are being, what is called as, rather than the voice communication, what we'll do with the data transfer? What we'll do with the data transfer? What happens here is, in the first step, sender sends to the IP address of MN, HA intercepts packet. So what is nothing but what happens with the voice communication? The sender is going to be sending the IP address to the MN router. That is the mobile node router. The router is going to be, the home agent is going to be intercepting that particular packet to identify that what is the identity of this particular correspondent node. So then it identifies that the correspondent MN with which the CN is going to be want to communicating is not present in the home net, and it is being moved to the foreign network. So what it has to do is, the home agent HA is going to be tunneling the packet to COA, here FA by encapsulation. That is nothing but the corresponding data will be tunneled to that particular foreign agent, and from that particular tunneled foreign agent, the data will be get encapsulated, that is protected in a protected way. It is going to be sent to the mobile node. So okay, so from the mobile node, again the communication reverse happens. That is, for foreign agent forwards the packet to the MN, right? In the reverse, what happens? That is, again the MN has to communicate with the CN. In the previous case, the CN is going to be communicated it to the MN, that is, send the packet to the MN in the first way, or in the one side way, and in the second side, okay, and in the reverse side, the MN has to get communicated with the CN. Simply, MN is going to be sending the data through the foreign agent router directly to the address of the CN. Okay, so why? Because here the FA will become the default router of MN. The communication continues in between the CN and the MN here. This is how the data transfer will be taking place in mobile IP whenever the mobile node is being moved from home network to the foreign network. And coming to the working of the mobile IP. So what happens actually internally, what happens while moving with the mobile nodes, while moving with the correspondent nodes, while changing the addresses, how the addresses will be get assigned, how the locations will be identified, how the correspondent moving users will be get identified, and to get received with that, to get connected with the correspondent nodes, how our identification will be helpful in order to find out the correspondent nodes, that is the partner nodes, so with which we are being communicating. So as we are being communicating in a static way, we are being reminded to the static position. Our geolocations will not be changed at all. But as we are moving, our identification has to be get identified by all the home networks. And again, our receiver's identification has also to be get identified by the home networks. And they has to frame a path in between ourselves and also our partner, so that we want to communicate or we want to continue our communication, right? So in that case, how the mobile IP is going to be working internally in order to continue our communication with our partners without any break, even though in case of a single partner or maybe in case of multiple partners. That is what we have to say. See, here we can say that the mobile IP addresses are of 2 categories. As we know that one is the one home address and another one is the one care of address. Home address is the one to which our home network belongs to. That is with which we belong to. The network to which we belongs to becomes our home network. And whenever we are moving, we enter into our another network or a new network, which is called as the foreign network, right? So in that particular foreign network, our address will be different. That will be called as the care of address. So any mobile node will be having a home address, which is a constant and a own address of it. And another one is a care of address, which will be changing. It can be changed over whenever it is been moving over different home networks, right? To make the address transparency, to the internet from all the foreign agents and the home agents and whatever it is, and whatever will be the receivers with which we are being communicating, the corresponding care of addresses will be get assigned. That is, with the particular care of addresses may be of what is called as already we discussed about, that is called as the foreign agent care of address is there, and also co-located care of address. Again, 2 categories. So in order to have the transparency, 2 types of care of addresses we can know about. That is about that is one of the thing is what is called as foreign agent care of address, and next one is the co-located. Foreign agent is already, we know that it is the permanent address given to that particular permanent COA, not the permanent IP. It's a permanent COA given to a particular subscriber. Whenever he enters into the foreign network, he has been given a certain identification as he wants to stay in that particular place until he completes the communication. That is called as the foreign agent COA. Whereas if he is moving continuously and not pertaining to any specific home network, not for a long interval of time, then he will be allocated with the co-located COA, right? So to communicate with the remote host or the mobile host, host goes through the three phases, so that as it may be a constant host or maybe a mobilizing host and whatever it is, if it wants to communicate with some other partner at a remote place, or that particular host or the particular partner is going to be moving over different places, it is going to be undergoing three phases. That is, while communicating in the mobile IP, we may go under three phases. That is, for establishing a connection between the party, to continue the communication, or to adjust the other customers, and to end the communication. For all these things, we have to undergo three phases. Okay, any host which initiated the communication of the call or communication of the messages and whatever it is with the partners, it has to undergo three phases. What are these three phases? These three phases will give you the total working procedure of the mobile IP, which is very different from the normal IP working. Okay, which is different from the normal IP working. So what are these three phases which are to be undergone by any mobile IP in order to continue the call with the partner? Those are nothing but the agent discovery, registration, and data transfer. What are these three phases? Agent discovery, registration, and data transfer. So what are these three phases? So that these are going to be making the mobile IP to work. Okay, these are the ones which are making the mobile IP to work. So what is that agent discovery? What is a registration? And what is a data transfer? And coming to the first one, that is agent discovery. See, a mobile node has to find a foreign agent whenever it is going to be moving, right? Whenever where the agent has to be find out, our home agent couldn't be find out. Why? Because it's our own agent. There is no need of finding out the particular agent. Why? Because we are every time we are being sticking onto our home agent itself. Our identification will be known only through the home agent. It is going to be assigning you the IP address, your location, and your identification will only given by the home agent itself. But whenever you are moving to the foreign network, then you will be you have to identify by that foreign agent of that particular foreign network. So that you have to find out the foreign agent first in order to have your identification to be exposed. In order to have your identification to be exposed, first you have to find out the foreign agent. So that for that one, what happens here is the agent advertisement and agent solicitation methods has to be followed. That is, the mobile IP is going to follow in two methodologies in order to find out the corresponding foreign agent that by a particular mobile host. What are those? Agent advertisement and agent solicitation. Okay, what are these agent advertisement and agent solicitation? We'll see. Agent advertisement, right? See, what happens here is every time, not only a particular, we have been actually talking about the mobile host moving from home network to the foreign network, right? But in common, the mobile IP is going to following this agent advertisement procedure or agent discovery procedure, agent solicitation procedure, and identification and data transfer. All these things are going to be commonly followed by all the type of the procedures. That is, whether it may be a home host or maybe the receiver and whatever it is, right? Here, what happens here is foreign agents and the home agents advertising themselves periodically using a special messages called as agent advertising message. That is, as mobile hosts are being searching for the advertising agents or the agents that they are been working over and they are been nearby to give their identification. Why? Because mobiles has to be get identified, their connection has to be get built up with the partners. So in order to get identified in the networks, in the foreign networks, we have to find out the agents over there. For that one, instead of mobiles are going to be waving over for the agents, the agents itself are going to be advertising themselves that there we are, there we are for you to help. That is, the agents itself, they are going to be advertising themselves by broadcasting certain messages as into the subnet periodically to give the identification for the mobile host to find themselves. Okay, so that a particular, no specific packets and no specific IP values or IP payloads will be used here. We are going to be using the packet of the ICMP. Already you know about what is this ICMP, Internet Control Message Protocol. Internet Control Message Protocol. With this particular ICMP, we will be having a particular packet. Using that particular packet of the ICMP, which is used for security and to get identify the synchronization in between the two parties who are being communicating, you'll be using the ICMP. The name itself is going to be explaining what is that Internet Control Message Protocol. That is Internet Control Message Protocol. It's going to be controlling everything, that how the messages are being conveyed between the two communicating parties, whether they are being synchronized or not, whether the message has been intended for the proper destined node or not, whether it is received by that particular node properly or not, whether it has been misused by any other node in between. All these things will be taken care by the ICMP. So using the ICMP packet itself, our agents are going to be periodically they are going to be sending the messages called as agent advertising messages. They are going to be appending their advertising messages to the packet of the ICMP itself. Okay, so what that packet will look like and how it will be taking place. So here we are going to be discussing about the packet format of RFC 1256. Now we're talking about RFC 1256. So this is a standard packet format. Here we are been discussing about the format of that particular standard. So what is this? The two parts, I mean, the total ICMP packet has been divided into two parts. One is the upper part and one is the lower part. Upper part has been only the ICMP packet, and lower part pertaining to our actual mobile IP. That is the mobility text that is required for our mobile IP communication, where our actual data is being going to be filling, right? So we'll see according to this lower part of mobility text, how the upper part is going to be changed. Actually, in the normal IP communication, upper part will be different. That is, what is the type of the message that you are going to send, what is the code that is being given for identification, for the what is the checksum value for the error correction, what is the lifetime of that particular packet, when it is going to be expiring, what is the address size, what are all the addresses, what are the routers through which it has to flow through. All these things will be identified in the normal ICMP packet, right? There will not be any other two parts. The total part of the ICMP will be unique in the normal IP communication. But coming to our mobile IP communication, we need the data from the ICMP, and at the same time we need the additional functionality for the mobile communication, right? We need the additional functionality of the mobile communication along with the ICMP. Why? Because we need the control, message control, we need the synchronization control, which has been happened with the ICMP packet, and at the same moment we want to connect with the mobile parties, right? For that one, you are going to use the mobility text. So that the total ICMP packet has been divided into two parts like this, right? So the upper part is consisting of which parts? Direct 1, 2, 3, 4. That is the 4 bytes of the data at the top layer, and next one is the type, and next one is the code, checksum, addresses, address size, next lifetime, router address 1, preference levels, router address 2, preference level 2. In that way, how many people we are going to be sending the data that are going to be given here. Next, coming to the lower part where our mobile IP is been especially using here, type is given as a 16, length field is there, sequencing number is there, registration lifetime is there, and other fields or flags or bits, whatever we say, a single bits are there, R, B, H, F, M, G, R, T, and next one is the reserved is there, COA1 and COA2. So these are all the parts which are belonging to especially our mobile IP, right? So what this advertisement packet has to be waived by the advertisement agent, both by the foreign agent and both by the home agent every time in order to get identified by the mobile hosts. Why? Because mobile hosts are going to be looking for these agents whenever they enter into the foreign network from their home network. So that to have their own identification, they have to find out the agents, right? So that the agents has to be get identified. So as you already know about that, while sea sailing or the sea journey, the ships are going to be traveling towards their destination. But whenever you are going to middle of the sea, we couldn't identify the directions at all. Even though you are in the middle of the sea, you couldn't identify the directions to which direction you are being moving. In order to have the identification, we do follow some compass. Okay, so using that particular compass, you are going to identify that in which direction you are going. But where do we identify the shore? When do I identify the shore is being reaching? How much of distance is there? Whether there is a particular shore on that particular side or not, in order to halt over. To identify the shore, we'll have the identification, that is the lighthouse. So with the help of the lighthouse itself, the ships or steamers or whatever it is, sea sailors, all are going to be identifying their shores with the help of the corresponding lighthouse itself. The lighthouse is going to be continuously giving the light beaming up. It's going to be revolving and it's also going to be beaming up, right? So that is the one of the identification. In the similar way, here our agents are going to be periodically giving their advertisement packets outside to get identified by the corresponding mobile host stations, right? So see, already everybody please keep in mind that what is the packet and what are all the different fields and what is the lower part of this particular mobility extension that is being given for the ICMP for the uses of the mobile IP communication. See, agent advertisement packet, what are all its fields and how it is being given. So, right, what it is. So the TTL field, that's the TTL field of the IP packet is set to 1 for advertisement to avoid forwarding them. So ICMP packet is meant for advertisement. It has been identified by the TTL field. Whenever the TTL field of the ICMP packet is set to 1, it could be identified as an advertisement message instead of the forwarding message. So whenever a particular sender or the transmission medium or the router identifies that the TTL field of the ICMP packet is 1, then it won't forward that particular packet, but it is going to be blinking over to identify or to give an what is called as impact that it is an advertisement, not the forwarding messages. It's not a data packet, it's an advertisement packet. It can be identified by the TTL field. Okay, and next one is here the type. So coming to the type field, type is set to 9. The code can be 0 also. Type is set to 9, but the code can be also 0. So when this particular thing will be used, if the agent also routes traffic from non-mobile nodes. So when this particular 0 will be set, when this particular 0 will be set, type is going to be set to 9 whenever the packet is only advertisement, not the data packet, right? Whenever the particular packet is advertisement packet, the type will be set to 9. And the code can be 0, if the agent routes the data traffic of the non-mobile nodes. So if the data packet is off, only the non-mobile communication, it's a static mobile communication, static telephone communication, then the code will be set as 0 in the code field. Otherwise, it will be set to 16 if does not routing any other than mobile traffic. Other than any other traffic, if it is only be routing only the mobile traffic, then the code field will be set to 16. Okay, the code can be either 0 or 16, 0 in case of non-mobile traffic and 16 in case of mobile traffic itself. And coming to the next one, that is the number of addresses. Okay, hash address. The number of addresses advertised with this packet is in number of addresses, while the addresses themselves call as shown. Right. So this particular hash addresses field is going to be showing you that how many number of addressing packets has been delivered until this time. So that count will be get noted in that particular moment. So what this particular addresses is going to be giving you. So if the address is lifetime, well, the addresses themselves follow as shown. So if the address is lifetime, denotes the length of time this advertisement is valid. That is nothing but how much of it is going to be valid for, how much time it is going to be get valid, how much time that particular advertisement is going to be get valid. After that, it is going to be getting expired. Next one is preference levels. Already we know this here. This is are being given here, right? So these are the preference levels. This is the address size, the number of addresses we have saw. This is the lifetime of the particular packet. Okay, code we have already explained. Type is also explained. Type has been given 9. Code is either 0 or 16. Addresses are total number of advertising packets that are being delivered, and lifetime is nothing but the total expiry period of that particular packet and preference levels. What is this preference levels are nothing but help a node to choose the router that is most eager to send or to get a new node. That is nothing but it is going to be allocating a router for a particular node which is willing to send the information. So whether any node is been now trying to send the information, then it is going to be identifying or it is going to be in search of a router, then these preference levels will be chosen, and these preference levels are going to be opting that particular node in order to send the data through that particular level. So depending upon the node level, the preference level will be chosen, and through that particular preference level itself, the corresponding node will be sending the data, right? And coming to the extension mobility fields, we discussed about only the upper part, right? Only the type is been discussed, code is been discussed, addresses, address lines, routers, and the preference levels, right? Now we are discussing about the lower part, that is the mobile extension part of the ICMP packet, right? Why the type is given as 16? Type is set as 16, giving that the mobile communication is going on. Type is 16 is nothing but mobile communication is going on, and length depends on the number of COAs provided with the message and equals 6 plus 4. That's nothing but total 10 addresses can be accommodated. Total 10 addresses can be accommodated, and that depending upon the number of COAs that you are being sending with each and every message. That is uh, through how many number of foreign networks it has to travel through. That is one packet or one user is going to be moving over, and he has to be get allocated with number of COS as he is moving, right? It is usual that he is going to be crossing many number of home networks, I mean foreign networks, while he is traveling or while he is in journey. So in that case, he has to be get identify that how many number of COS has been allocated in his journey until he completes the communication. That is what it is been noting. Length is going to be depending noting the number of COS that are being allocated to the message. Okay. And next one is sequence number. Next field is sequence number, which is showing the total number of advertisement sent since initialization by the agent. So once the agent has been initialized its communication, it is going to be identifying how many total number of advertisements has been sent. That sequence number will be get identified here. So right from the initialization, not from the single communication, right from the total initialization of the communication itself, how many number of advertisements has been gone, not only between the two parties, but right from the origin of the communication, how many number of advertisements has been blown up. That will be given in the sequence number, right? Next one is the registration lifetime. The agent can specify the maximum lifetime in seconds a node can request during registration. That is nothing but whenever any node has to communicate, it has to approach the agent. At that agent, it has to get registration. Using the particular registration itself, its lifetime will be get identified. That is based on the time interval. That is a maximum lifetime a particular node can request particular registration at that particular point or at that particular agent to transfer the data through it. That is why, because using the particular agent itself, we are transferring the data. So after registration of the corresponding node with the corresponding agent, the lifetime will be get defined. After that lifetime, it has to re-register. Until that particular lifetime, the node can send the data through the same home agent until it lifetime gets expires. Okay, these are about the fields of the corresponding node. Extension mobility, right? What we have discussed about, we discussed about the type, we discussed about the length, sequence number, and also the registration, right? Length is nothing but the total number of what is called as how many number of advertisement messages sent from corresponding, I mean COIs that are being sent as a message, and sequence number is the total number of what is called as advertisement sent from the origin of the communication, and registration lifetime is the time period of the corresponding node that can send the messages through the same agent where it is been registered. And coming to this fields R, B, H, F, M, G, R, T are there, right? What are all these fields which are been pertaining to which particular thing? All these things we see. See, these are all nothing but the characteristics of an agent. So these bits or these flags are going to identifying you, or they are going to explaining you the characteristics of an agent. So R bit is going to be showing if the registration is required even when using a co-located COA at the end. That is, if a registration with this agent is required even when using a co-located COA at the MN. For example, if you are being moving over, you are in a journey, you will be allocated only with the co-located COA. But even you are being using the co-located COA, but if you require any registration with that particular agent, then the bit is going to be showing that even though you are being allocated the COA, you have been registered at that particular agent. That bit is going to be enabling, shows that your registration has been done at that particular agent, even you are only allocated with the co-located COA, right? So if the agent is currently too busy to accept new registrations, if the corresponding agent doesn't accept any registrations from the new nodes, then it is going to be setting the B bit. If B is 1, indicating that the agent won't accept any type of new registrations. That is, no node can enter into the communication through that particular agent. That is the B bit. Next one is H and F bits. These two bits are going to be indicating the services, which service the agent is been acting. That is, at which service the agent is been acting as now, whether it is acting as a home agent or whether it is acting as a foreign agent, that can be identified using the corresponding bits. If the H is enabled, it is been acting as a home agent. If F is enabled, it is going to be acting as a foreign agent, right? While IP in IP encapsulation is a mandatory standard, right? Next one is the R has been decided, B has been decided. Next one is the IP in IP encapsulation. That is the encapsulation procedure where we are going to be communicating in between the two mobile points. There we need the encapsulation, right? There could be in between the foreign agent and the corresponding mobile node. There could be there we need the encapsulation procedure, and it is a mandatory. And whenever we specify M bit, M can specify minimal encapsulation, and G is nothing but the generic routing encapsulation. So whenever we encounter, when we go through this encapsulation procedure, we can know about what is this minimal encapsulation and what is the generic routing encapsulation. So depending upon the encapsulation procedure, it is going to follow. Either we will be get enabled with the M, or either will be get enabled with the G. So if it is an M, it is going to be specifying it is following the minimal encapsulation procedure right from the router to the particular user. Otherwise, if G is enabled, it is indicating that generic routing encapsulation is followed by the router in between the communicating nodes, right? These are all the bits. And next one is in the first version of mobile IP. The first version of the mobile IP came into existence in the 2002 at the standard of RFC. The V is going to be specified the use of header compression across, according to RFC 1144. So according to the RFC 1144, that is nothing but the IP communication. That is of the mobile, IP communication standard. According to the RFC IP communication standard 1144, the header compression is going to be seen with. That is, whenever V is being highlighted, it could be identified that the data that is being sending over the corresponding agent is nothing but the IP data. That is nothing but the normal IP communication, not the mobile IP communication, right? The header compression is being done at IP level, not at the mobile IP level. So now the field R at the same bit position is set to 0 and must be ignored. So then at that moment, whenever the corresponding agent is going to be only forwarding the IP data, not the mobile IP data, then the R will be set to 0 and can be ignored. Otherwise, if that particular V bit is not set, R is going to be set to 1, indicating that now the mobile IP communication is going on. Header compression of the mobile IP, not the header compression of the IP communication, it indicates, right? Next one is the T field, which is going to indicating the reverse tunneling followed up or supported by the foreign agent. So what is this tunneling? What is this encapsulation? Types of the encapsulations, all this we can see. There while discussing about the encapsulation and the tunneling procedure, we'll come again with this particular format again. Okay. And next one is the COAs. Already COA 1 and COA 2 are there in the lower part or extension part of the advertising message. So what is the COAs are consisting is nothing but foreign agent setting the FPIT must advertise at least one COA. That is nothing but whenever a foreign agent is going to be setting the FBIT, that is, if it is been acting as a foreign agent, it has to at least advertise one COA. Okay, then the mobile node is going to be receiving the agent advertisements from either its home or a foreign agent. This is one of the element to discover its location. That is COA. While advertising the COAs, we have to know about, so what is the type, what is the registration lifetime, what is the length, what is the sequence number, what is the R bit, what is the B, is the home agent, foreign agent, and M is going to be enabled at which point, F is going to, G is enabled at which point, R when it is, T is for the tunneling, and CO is for the care of address whenever the corresponding agent has been acting as a foreign agent exposing the COA. At least one COA is going to be exposing. Right. Right. So we'll be discussing about the agent solicitation, and we'll have also review of this agent advertisement in the next class. Right.